A number pattern, also known as a number sequence, is a list of numbers that are ordered according to a rule. Each number in the sequence is called a term. Linear number patterns, specifically, are made by adding the same value each time. This means that there is a constant difference between consecutive terms. Some terminology that you need to be familiar with is something we call the general term Tn. The general term Tn can be used to find the value of any term in the sequence. It can also be used to find the position of a specific term in the sequence. Let's look at an example of linear patterns. For the following number pattern, 20, 15, 10, and 5, extend the pattern by 3 terms, and 2, find the general rule. For the first part, let's see how we can extend this pattern. To get from 20 to 15, we see that what is needed to do is subtract 5. To get from 15 to 10, we subtract 5. To get from 10 to 5, we subtract 5. We can tell that this is a linear number pattern because there is a constant difference between the consecutive terms. Each number in this pattern, 20, 15, 10, and 5, are called the terms. We know what follows the term with a value of 5. All we need to do is extend the pattern by subtracting 5 each time. 5 minus 5 will give us 0. Once again, to 0 we subtract 5 to get negative 5, and again subtracting 5 to get negative 10. These are the next 3 terms in this number pattern. We cannot continue adding this negative 5 indefinitely. We need a rule that brings it all together. And the next part says, find the general rule, Tn. We'll be working with a method in order to do this. We can set up a table. What you will see is we're going to relate the position of each of the terms, where they sit in the sequence, with the value of the term. We're also going to add a row in with multiples of negative 5. The reason we have multiples of negative 5 is because negative 5 was the constant difference in this number pattern. We saw that the term in the first position was 20. The term in the second position was 15. The term in the third position was 10, and the term in the fourth position was 5. We then put in a row where we list the multiples of negative 5. We'll multiply that constant difference to the term position, and we'll see how we can relate this multiple that we've created to the actual value of the term. If we want to get from minus 5 to 20, what do we have to do? We need to add 25. 25 minus 5 will give us 20. We now look at position 2. Minus 5 times the position, which is 2, minus 5 times 2 gives us negative 10. When we want to get from negative 10 to 15, what do we do? Once again, we add 25. You should be able to see that there is a pattern forming. So we're getting the general rule by looking at the position of the term and the term value. In the next one, we've got minus 5 times 3, which is minus 15. The term in position 3 is 10. How do we get from negative 15 to 10? We add 25. Lastly, we've got negative 5 times position 4, which is 20. The term value is 5. So how do we get from minus 20 to 5? Again, we add 25. What we've seen is each time we've taken the constant difference, we've multiplied it by the position of the term and then added 25. This is what we call the general term, because it can be used to work out any term in the sequence. Formally, we can say that Tn, our general term, is equal to minus 5 times n plus 25. So what we did was we took the multiple of that constant difference and then added 25, depending on the position of each of the terms, to give us each the value of these terms in these specific positions.